Good morning, Year 7. So today we are going to do a little bit of extra work on the moon. I must say I was really impressed by the research that you did. You've had 18 uploaded so far. I do need the rest though. So firstly, we're going to understand how the moon affects the Earth. So by the end of today, all of you should know if the moon is luminous or non-luminous and explain the difference. Most of you to be able to explain why the moon appears different shapes at night, and a few of you relate the phases of the moon to its orbit around the Earth. So, to begin with, a few things about the moon, hopefully, you might already know from your research. So, there is something called a full and a crescent moon, but what does that mean? It orbits the Earth in 28 days, so it goes around the Earth. It can influence tides, and I'm going to explain how that happens. It's made of rock. On June 14th in 1969, Neil Armstrong became the first man to walk on the moon. And there are lots of craters on the moon because it's been hit by lots of meteors in its history. So, a few other little things about the moon. Actually, no, this can be your first task, okay? So these statements are incorrect. What I would like you to do is pause the video and rewrite them so that they are now correct. So these are 3 statements. Okay, pause the video and off you go, please. So just so I can squeeze them in, I have made them different colors so you can see them. So there we go. We see the moon because it's luminous, the sun rotates around the Earth, and the Earth is bigger than the sun and moon. Okay, so write these so they are now correct. Okay, welcome back. So what you could have written for this first one was not because we see the moon because it's luminous. The moon doesn't give off its own light, it reflects sunlight. So we see the moon because light is reflected from the sun onto the surface of the moon and into our eyes, something like that. The sun rotates around the Earth. Well, that's not right. The Earth rotates around the sun, okay? That's what we call a year. The Earth is bigger than the sun and moon. Well, that's not correct either. The Earth is bigger than the moon, but it is smaller than the sun. And just to give you a quick size comparison, if you held them up against each other, see the sun is so big, it doesn't even fit into this picture. By comparison, the Earth is that big, and the moon compared to the Earth is that big. Okay, the reason the moon looks pretty big in our sky, say compared to the sun, is because it's so much closer to the Earth than the Earth is to the sun. Okay. Okay, so a couple of key facts for you. The moon is non-luminous. It reflects light from the sun. Now, if you didn't get that, that should be on your notes from last lesson. The moon has no atmosphere, which means there is no life. The moon is much smaller than the Earth. The moon orbits the Earth and is held in this orbit by the pull of gravity. And we say that the moon is Earth's satellite. Now, usually we think of a satellite as something man-made going around the Earth, and that is true. But anything that goes around the planet that orbits, we call a satellite. And the moon does go around the Earth, so we call it a natural satellite because it's not put there by people, it exists naturally. And then a complete orbit of the moon takes about 1 month, about 28 days. Okay, so your first task is this. What I would like you to do is pause this video now, and I would like you to go into assignments and watch the 2 short documentaries. They're about 3 minutes and about 4 minutes long each. And then there is the first task called I think it's just called Moon Sheet. And what you need to do is fill in the blanks. Now you should have most of the information you need. Okay, so have a go at that. So pause this video now, go into assignments, watch the 2 documentaries, and then have a go at the first task, which is called Moon Sheet, which is fill in the blanks. Okay, off you go, please. Okay, welcome back. So sometimes we can see the moon during the day, and but it's actually quite difficult to see. Why is that? Well, remember, the moon is non-luminous. It's not giving off its own light. It's reflecting light. So when we have a bright, clear blue sky, it's more difficult to actually see the moon. But the moon is actually really important for life. Without the moon, there would be no life because it's done several things. It slowed the spin of the Earth and lengthened our day from about 6 to about 24 hours. And it stabilized Earth spinning on its axis. Before that, before Earth had a moon, it used to spin a lot on its axis. Well, because of the rotation of the moon around the Earth, it's nice and stable, giving us these gentle seasons. Okay, if not, the Earth would probably not be very habitable for life. But one of the key things is, you've probably heard of the phases of the moon. That's when, if you look at the night sky, sometimes you get a full moon, sometimes you get a crescent moon, sometimes you get a half moon, sometimes you get something called a new moon, where you can't see the moon at all. So why does this happen? Right, so what I'm going to do is your second task, which is phases of the moon sheet, okay, I'm going to give you a task like this. Now I want you to use your imagination a bit. Imagine you are standing on the Earth. So, apologies, I never got beyond drawing stickmen. I am rubbish at art, but let's put you on the Earth. There you are. Now, let's just say we know the moon goes round the Earth like this, and there's the sun giving light. Now, let's think logically for a minute. If the sun is giving off light, what will we see? Okay, so here the sun's beams of light, there they are, coming in, they're hitting the moon, but they're hitting this side of the moon. Will you be able to see the sun's light? Well, the sun's light basically lights up this side of the moon, but this side of the moon is going to be dark. Oh, did that wrong, bear with me. Sorry about that. So what you would get is this, okay? So the sun is shining on this side of the moon, but you only see the dark side of the moon. However, what happened by the other side of the month is this, okay? Okay, welcome back. So now the moon has moved here, moved round the Earth, and now the sun's beams hit the surface of the moon, bounce off the surface of the moon and into your eyes. That's how we see it. But of course, we can't see this side. So to us, it appears as a full moon, okay, because we can see this entire side here. All right. So there are a few other phases which I'm going to give you very quickly. Okay, so just quickly talk you through what's going to happen here. So while we're at this phase, beams of light from the sun hit the surface of the moon and bounce into your eyes. Now, what you can see is half of the moon. So that would be a half moon. So you've got these different phases, but there are several phases of the moon as it goes from a new moon, where you can't see it at all, around to a half moon, and then to a full moon. So what you've got is a sheet called Phases of the Moon. What you need to do is cut the different phases of the moon out and stick them in the right place. And the first one's been done for you, and hopefully that will allow you to work that out. That should probably take you about 5 or 10 minutes to do. So pause the video and have a go at that, please, now. Sorry, quick update. The picture on your worksheet, Phase of the Moon, is like this. Okay, so you've got these cutouts of the phases of the moon. You need to stick them in the right order, and the first one has been done for you. Okay. Okay, welcome back, Year 7. So one of the really cool things that a lot of people don't realise is that the moon is responsible for giving us the Earth's tides, the oceanic tides. So the reason that works is because there's gravity between the Earth and the moon. So if I just draw in a little arrow, okay, there's a gravitational attraction between the Earth and the moon. And so the moon pulls on Earth a little bit, even though Earth pulls on the moon as well. So basically what's happening is the moon is basically tugging or pulling the Earth's ocean up towards it, only a little bit, okay, but essentially the Earth's oceans, if we imagine them as sort of giant oceans like this, I'm just going to sort of put this in place. So imagine the oceans this sort of oval shape is the oceans, sort of swelling around the Earth. Oops. Then what happens is, at the point where the moon passes, the oceans get pulled towards the Earth. Usually they've been a perfect circle, nice and level and even around the Earth, but the moon's gravity basically pulls the oceans up towards it because water can move. Now, not by much, only by about a meter or two, okay, but that's enough to give us the tides, okay? So the first thing I'd like to do is very quickly pause the video, and I'd like you to draw in a diagram like this with an explanation. So you could say something along the lines of the pull of the moon's gravity pulls the ocean towards it. This gives us high and low tide. Okay, now this is a very simple diagram, okay, and don't worry if you don't really understand all of it. Why does it also swell on this side? Don't need to know that just yet. But the pull of the moon's gravity sort of pulls the ocean off the surface of the Earth just a little bit up towards it, okay, only by about a meter or two, and that gives us high and low tides, okay? So pause the video and just add this diagram into your book, please. Right, welcome back. So your final task for today, this should probably take you about 10-15 minutes and will bring you up to the end of the lesson. The moon's gravity pulls on the Earth. The solid Earth can't move, but the water in the seas and ocean is pulled towards the moon, and this causes tides. Okay, this you know from your last diagram. The table shows the height of the highest and lowest tide in the Bay of Bristol and phases of the moon during the month. Okay, so for example, on day 1, it would be a full moon. The highest tide is 12.2 meters and the lowest tide is 1.5 meters. Okay, so the difference between the high and low tides is called the tidal range. So make a table showing the moon phase and date and a tidal range like this. So I'm just going to show you on the next page. So what you've got is, you've got the phase of the moon, 3 and 11.5. Now, how did you get that? Well, if we go back and have a look, well, there's 3, and there was the phase of the moon. So if we have a look, we have 12.8 and 1.3. Now, this involves a little bit of calculation, because if you get your calculator out, oops, sorry, got a bit far. Do 12.8 minus 1.3 gives us 11.5. So in this case, the tidal range was 11.5. Now, what I would like you to do is to work out the tidal range for each of these dates. You'll notice it goes up in 2, so 1, 3, 5, 7, 9, and this is a day. Okay, so for example, this one, I would do 12.2 minus 1.5. So let's just quickly do that. So clear, 12.2 minus 1.5. So here, oh, hang on, I just made a mistake there, sorry. 12.2 minus 1.5. Right, so here, the tidal range for day 1 is 10.7. For this one, it was 11.5. Okay, so what I'd like you to do is to work out the tidal range and then plot it on a graph like this. Now, if you've got graph paper at home, that's great. If not, you can use the lines in your book to try and plot it, but you do day 1, day 3, day 5, day 7, day 9, along the bottom, all the way up to day 31. So that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right, so 16 days. So you need 16 bars. If you want, you can draw the phase of the moon, but you don't have to if you don't want to, but it might help you to do that. And then the tidal range, okay? So you need to draw up the side. This is why graph or square paper would be good if you've got it, because what you can do is plot the tidal range on this first one. So here it'd be 10.7, then it'd be 11.5, and then all the rest of them. So that will probably take you to work out the tidal range and then plot it on a graph. That would probably take you between 15-20 minutes. So that should probably take you right up to the end of the lesson. If not, 5 minutes or so over. Okay. If you don't quite finish it, do as much as you can. If you really do need graph paper, I suppose don't tell the maths department I said this, but you can probably tear one sheet out of the back of your maths book. I'm sure they wouldn't mind in the interest of science, and then you can stick that down in your book. Okay. If not, if you're feeling very technical, you can do it on Excel. Right, ladies and gentlemen, I will be online to help you as always. Good luck, and see you later.